What's good, everybody? In this video, we're doing another SAT and ACT review. Really hope that this video is helpful for you. We're going to go over some complicated problems that you will see, and we're going to show you how you should approach them. So problem one says, if A, 2, -1, and B, 4, 7 are the endpoints of the diameter of a circle, what is the area? So first off, we know area for a circle is area is equal to pi times r squared. And when we look at this, we're going to have to find or not find, but use the distance formula so we can figure out what exactly is this diameter so that we could find the area. So when we think of the distance formula, we have x2 minus x1 squared, plus y2 minus y1 squared. So this is going to be the distance formula, and we're going to plug these points in to the corresponding parts. And I like to draw these lines just to make sure I add the correct numbers. So once we go in, we're going to have 2 minus 4 squared plus -1 minus 7 squared. When we simplify this, we're going to get -2 squared plus -8 squared. And in the next step, we're going to get 4 plus 64, and we know the distance will be radical 68. Now, when we think about this, this represents the diameter. We do not know what the radius is, and the way that we could figure out the radius is understanding the relationship between diameter and radius. The radius is half the diameter, but in this problem, we have a radical, and dividing a radical by a whole number is very challenging. So what we're going to do in this part of the problem is kind of change our area problem. And we're going to use area is equal to pi times half the diameter squared. So if we use this formula, we could then solve and figure out what the radius is and get the area. So let's erase this, and I'm going to show you guys what I mean. Now, if you use this formula, what we're going to have is area is equal to pi times radical 68 over 2 squared. Now, the reason why we had to use this formula is so that we could get rid of the radical. When we square radical 68, meaning we multiply it by itself, we get the same exact number. It's just without the radical. So now area is going to be equal to pi times 68 divided by 4. What I did was was square the radical, so we just have radical 68 and square 2 to get 4. Now at this step, I'm going to grab my calculator and we're going to do 68 divided by 4. So we know area is equal to pi times 17. And once we finish this problem, we know that our answer is going to be 17 pi, which is B. So if you're using area and you get a problem like this, just remember that we could substitute and use the second formula in a problem where we have a radical and we cannot divide by 2. But in our next problem, we're going to look at finding missing angles of a triangle. In this problem, guys, we're dealing with two triangles and they're asking us to find the missing angles. But there is a trick to this problem, and I really hope you guys stick around to figure out. So it asks us in the figure above, what is x plus y plus w plus z? See, now the biggest trick to this is we're all going to look and say, hey, a triangle is equal to 180 degrees. If I have two triangles, that means I'm going to add 180 plus 180 to equal 360, right? So if I add 320 and 40, that means D has to be my answer. But no, guys, unfortunately, that is the trick. So if you picked D, it is wrong. And I'm going to show you why. So let's look at the larger triangle, A, B, and C. So we know if we add angle A, 40 degrees, plus W, plus X, right? This is going to be equal to what? 180 degrees, right? When I now start solving for the equation by subtracting 40 on both sides, I'm left with w plus x on the left-hand side of the equation is equal to 140. So we're going to stop right there and let's just put a box around this. So that's the first part. Now I go back and I said, hey, let's do the same exact thing for triangle ADE. So I know that 40 degrees plus angle Z plus angle Y is equal to 180. When I go ahead and solve, meaning I simplify by subtracting 40, I'm going to get Z plus Y is equal to 140. So now at this step, we're noticing something. W plus X is equal to 140. Z plus Y is equal to 140. So what does this mean? It means in the figure above, what is X plus Y plus W plus Z? If W plus X is equal to 140 and Z plus Y is equal to 140, if we add all four of those angles up, we must get 140 plus 140, which would be 280 degrees. So the actual answer would actually be B. And please do not fall for this trick. It's a concept question. They're trying to see if you actually spent time analyzing the problem versus just looking at 40 and subtracting it from 360, like I said in the first problem. But now we're going to go on to simplifying rational expressions and factoring in our next example. When we're dealing with rational expressions, guys, the first most important thing is for us to try to factor and simplify. So when I look at this top right, I always tell students if there is a number in front of the x squared term or the leading term, always check for a greatest common factor. So I could take out a 2. When I take out a 2, this turns into x squared minus 4. And we have to come back to this because this is the difference of two squares, meaning we could factor this even further. But let's just go down to the bottom and start factoring that. So in the bottom now, I'm looking for factors that when I multiply, it's going to give me 4, and when I add, it's going to give me 2. So because I'm very good, or I know my factoring rules, I know that when C is positive, right, that means the signs are going to be the same for the factors, whether they're both positive or both negative. So we're going to get a positive 4 when we multiply, a negative 4 when we add. So that means we have to have x minus 2 times x minus 2. When we add both of these negative 2's, we'll get negative 4. But when we multiply, we will get positive 4. So now at this step, we still have to factor the top. So now we go one more step and we have 2 times x plus 2 times x minus 2. All over x minus 2 times x minus 2. And just remember that equivalent expressions mean that they have the same value or they're the same exact answer, okay? So if I wanted a fraction equivalent to 1/2, right, that's the same thing as 5 over 10. That is still considered 1/2. Or it could just be 1/2 as well. That's equivalent to 1/2. So now at this step, we factored everything completely and I could cancel where possible. So when I look up here, there's an x minus 2 on the top and I could cancel that with an x minus 2 at the bottom. And as a result, what I'm left over with is 2 multiplied by x plus 2 in the numerator all over x minus 2. And this answer choice is going to give us B. When we're working with rational expressions, guys, factoring is going to be the most important thing. So please remember those tips. Leading term, if there's a number greater than 1, check for your greatest common factor. And if you see the difference of squares, just make sure that you check for it. Or if there's no middle term, like in this problem right here, just double check to make sure it's not a difference of squares. And in our next problem now, we're going to be looking at properties of exponents and how to simplify given an expression. In our properties of exponents video, guys, they're asking us to simplify an expression and pick the equivalent answer. But the biggest challenge in this problem is making sure that we know our exponent rules. Because if you go in here and you say, hey, I'm going to multiply my base with the exponent, we could easily get 8. So we could do 3 times 3 to get 9. 2 plus 3 to get a to the fifth, and b to the 3 plus 3, which will give us b to the sixth. But these are the incorrect exponent rules. So a would not be right, but if you don't know your rules, you could get easily confused. Now, let's say you go in and you apply the power to everything. So you take 3 to the third power and get 27. 2 to the third power, you get a to the eighth, and 3 to the third power, and you get b to the 27th. You would get E as the answer choice. But this is also incorrect. Peters, yes, sir. What is the actual way to properly do this? I'm glad you guys asked. So let me show you exactly how to do it. And it's actually a mixture from these two incorrect examples. And this is what I mean. So when we have the number, we're going to take the number to the power, meaning 3 times 3 times 3. So we know 3 to the third power is 27. So we could cross out answer choice B because we know that's incorrect. So with that being said, let's just erase this. We know 3 to the third power is 27. And anytime we have one exponent being raised to the other, we multiply them. So for A, if we take 2 multiplied by 3, we're going to get a to the sixth. And if we go back and do the same thing with B to the third, 3 times 3 is going to give me B to the ninth power. And our actual answer would be D. So properties of exponents is always a very popular topic on the SAT and the ACT. It's important that you just try to remember the rules or the certain aspects so that you can maneuver to your correct answer. And with that being said, we're going to move on to radical equations and how to solve for a radical. In this radical problem, guys, we need to figure out the value for x. But there's about one small thing or detail we need to make sure that we don't trip up on and make a mistake. And that's going to be 25 minus 3. So a lot of students are going to want to come in and subtract. But guys, this is one term right here, 3 radical x. They spaced it out a little bit to kind of try to trick us or fool us, right? The first step we should do is move 25 to the other side by subtracting. It's a positive 25, subtract it on this side, go to the other side, do the same thing. So we have negative 3 radical x is now equal to, and if I'm not mistaken, this should be, well, matter of fact, hold on, let's just make sure. It's been a long video, guys. Thank you for just dealing with this, all right? Yeah, it is 18. I knew it was 18. All right. So we have negative 18, right? And now what we want to do after subtracting 25 is continue to work on trying to get the radical by itself. This is how we solve radical equations. Always isolate. So because we're multiplying negative 3 in radical x, I'm going to divide by negative 3 so that I can move it from this side to the other. So I divide by negative 3 on this side, and I also divide on the opposite side, and I'll get radical x is equal to positive 6. Now, the very last step is for us to now get rid of the radical. And because it's a square root, we're going to take it to the power of 2. So I'm going to take this to the second power. What happens here is the exponent cancels out the radical. We're left with x is equal to. And then let's just make sure we don't forget to square the other side. So x is equal to 6 squared, which will be 36. And we know that our answer choice is supposed to be letter D. So when we're working with radical equations, guys, always remember that you want to get the variable by itself. And to now get rid of the radical after isolating it, we got to take it to its root or index. And in this example, it was 2 because we did not see a number. And with that being said, we're going to now move on to the last problem of the day with solving proportions and ratios. Moving on to the last example for this video, we're now dealing with proportions. And we hope that you found this SAT review helpful because that's the whole purpose. We're trying to make this math easier for you guys. So if 24 out of 40 students in the club are girls, what is the ratio for boys to girls in the club? So proportions is always a major topic that we're going to see on the SAT and ACT. So we have to be prepared. So the first thing we need to recognize is that they're asking for the ratio of boys to girls. But if we look at the example, we don't know how many boys there are. We know that there's a total of 40 students and there's 24 girls. So the first thing we need to do is find the difference so we can understand how many boys are there. So once we do that, we're gonna have 16 boys, right? Found the difference. Now we know there's 16 boys. So we have 16 boys to 24 girls. And now they want us to figure out the ratio, right? And this is the ratio right here, but we just need to reduce. So if I divide both of these by 8, right, this is going to turn into a ratio of 2 to 3. So the answer should be C. But before we wrap this video up, they were trying to trick you. So what they wanted us to do, right, was to basically do what we did, but not pay attention to boys to girls. So it would have been like, oh, okay, so we have 24 girls, and then we know that there's 16 boys. Because naturally, we're going to see this number and we're going to want to use it because we know the amount of girls. So just make sure that you set up the proportion correctly. Because if you didn't understand this part, or if you didn't catch it, you would have thought the ratio was girls to boys since they mentioned girls first. And when we simplify this, we could have got an answer of 3 to 2, right? Now, oh, sorry, I said before we go. Now, another thing that you could have messed up on, right? So we know this is wrong. We could have just looked at this and say, hey, we could have did a ratio of 24 to 40 just by moving fast because we did not think about, hey, I need to subtract. So imagine if you set up a proportion like this and then you simplified, right? Let's say we divide both sides by 4. We would have got, let's see, 10 here, and then this would be 6 here. Reduce even more, and we would get a 3 to 5 ratio. So do you see how we could have got the incorrect answers as well? That's why proportions are so important. Really hope this problem helped you out and explained the right steps versus the wrong steps. Thank you guys so much for joining us today on Algebra 1 with Mr. Peters. Smash the like button for us, subscribe to the channel, leave comments for future videos you guys would love to see on our channel, or if you just had some question on today's video, drop the comment down below. We'll definitely get back to you as soon as possible. Thank you guys for watching.